Advent of Code, Day 7, The Treachery of Whales. A giant whale has decided that your submarine is its next meal. It is much faster than you are. There is nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor, sensors indicate a massive underground cave system just beyond where they're aiming. The submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There is one major catch. The crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab. That will be our puzzle input. What I just highlighted was the example. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, these are the starting positions of the crabs. There's a crab in position 6, a crab in position 1, and so forth. And what we're going to do is between positions 0 and 16, we're going to pretend we're at each one of those positions 0, 1, 2, 3, 4, all the way up to 16. Add up how much fuel it would take to move each crab to that position. For example, if we are in position 2, it takes 14 fuel to move this crab to position 2. It takes 1 fuel to move this crab to position 2. Notice that the fuel amounts are not negative, so we'll need an absolute value. And we'll double check that we could replicate this example to get a total of 37 fuel. We are in day 7. What I have a hunch is that part 1 is going to be very easy to code, and part 2 I'm going to stumble quite a bit. So let's see how this works out. So we have our code. Our puzzle input is actually all these crabs here. But I'd rather do this for the example first, which were these 10 crabs. I'm briefly wondering why my first vector is not working. Sorry. ran into a technical difficulty. What's happening is I wanted to type in R code, but for some reason the R code was literally not running. So let's start this up again. So we have some R code. The puzzle input are these numbers here. And once again, for some reason, this is not running as intended. Let me just see if this works on the example first. And we'll come back to it. Okay. So what I'm thinking is that we have a minimum position and a maximum position. That is how far to the right we are. So we note that our numbers are, in this example, going from 0 to 16. So then, all possibilities are making a sequence from the minimum position to the maximum position. That is here in the bottom left. All possibilities, all those integers going from 0 to 16. Now, the field cost would be the absolute value of puzzle input minus all positions let's see. So all positions was a vector of 17 units, and this is not going to be a quick vectorized calculation as I thought off the top of my head. This, for part one, we'll settle for a for loop. So we have the minimum amount of fuel. I'm going to want to start this off as a very big number, and then as we find smaller and smaller fuel amounts, we will decrease the number. So I'll just put this as, say, 1 billion for now. And this fuel cost would then be the puzzle input minus this position is literally from all the positions. So we take that, where the crabs were, minus all possibilities for the horizontal position. That is, as we go through the all possibilities for the horizontal position. And if this fuel cost is lower than the minimum fuel that we found previously, we're going to update our information like so. And let me double check what we're looking for how much fuel must it spend. So we need that many units of fuel, and in the example they got 37, and I'm still messing that up. So let's see. If I have puzzle input, and this position should be the number 16, then puzzle input minus this position, I took the absolute value of those, but what I forgot to do was add up the numbers. So I need to put a summation here for this fuel cost. And that's how we get the 37 units of fuel. Remember, that's for the example. So now I need to run this on the big puzzle input. And for some reason, RStudio wasn't letting me hard code that or type that in directly. So I'm going to copy and paste this information into a text document. So puzzle input should be where we could read the lines of that file, and I'm going to string split that where there was a comma, and because I used the string split function that's coming from the string R package, I could just call the string R package once, but we'd still have part 2 to contend with, so we might need more than just this one function. So now the puzzle input has all 1,000 of those numbers. I have to convert them to numbers as well. When I run everything, the example worked, and the part 1 is done for the real input. See, just like yesterday, part 1 took about 10 minutes, not counting the technical difficulties I had at the beginning of today's session. So now we'll figure out what is here for part 2. The crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, submarine engines don't burn fuel at a constant rate. Instead, each change of one step of horizontal distance costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, third step costs 3, and so forth. As each crab moving further becomes more expensive. This changes the best horizontal position to align them all on. In the above example, this becomes position number 5. So let's parse this a bit. To move from 1 to 5, that's 4 units of horizontal direction. But the fuel cost is 1 plus 2 plus 3 plus 4. To move from 2 to 5, that's 3 units in the horizontal direction. So that's 1 plus 2 plus 3. Okay. So what you have, maybe I could just look this up. We're going to be using this formula here. The sum of the first n natural numbers is given by this formula. N times n plus 1 all divided by 2. So what I'm going to do, well, first I'd like to document my code a little better. What we're going to do is create a helper function. Actually, I could create a helper function, but it's going to slow us down in the long run. Having to call and create what's called a new environment for just this formula is going to be slightly inefficient. So instead, we're going to do this again. We're going to work on the example first. And the issue is that we need to change the metric, right? So we need n to be the absolute value of I'm getting ahead of myself here. So what I need to do is go through every one of the numbers in the puzzle input, compute the difference with this position. So what we had before is our puzzle input. This position is in the example is a number between 0 and 16. And to figure out the value of n for this formula, we need to take puzzle input minus this position and take the absolute value of that. So I'm going to get a bunch of numbers like this, and I want to plug in each one of these for n here. And I know there's probably some clever way to do this in R. I just want to spend a few seconds thinking about that. I think this actually still works out directly if I think about this. So n is what we just said, absolute value of that. And then what we want is this fuel cost is going to be n times n plus 1. This will literally add 1 to all the numbers in the displacement and then divide by 2. So if we run this on the example, and once again I forgot to sum up the fuel cost. If we run this on the example, the minimum fuel cost was 168. So now if I run this on the big example, we got the right answer because we knew some nice mathematics. The leaderboard must be like ridiculously fast. Let me check that. Look at this. People solved it in 2 minutes. And yeah. But I think we placed in the top 7,000 because it was a very easy puzzle today. Alright, folks. I know I said at the beginning I would try to explain things at an easier level and avoid efficiency, but I kind of went back on my word there. I'm gonna go ahead and upload this to YouTube and hopefully link a copy of the code as well. And well, we'll see you tomorrow.